Hello hackers! Today we will be creating your first blockchain application. This application will showcase the concept of blocks, blockchain, hashing, and validity of the blockchain. The application will not cover proof of work. This will be showcased in a different video. The prereq required for these projects are Node.js, Crypto.js used for hashing, and some knowledge of JavaScript. Let's begin setting up the project. Let's create a directory called mycoin, cd into that directory, and let's set up the npm project by running npm init. It will ask series of questions. For example, the package name, version number, description, entry point. In our case, it's going to be app.js, the keywords, the author, that could be your name, the license, which in this case is MIT. And when you accept it, it will create a package.json. You can use any of your favorite editor. I will be using Visual Studio Code to edit this project. So let's open this project we just created using npm in Visual Studio Code editor. So now you can see package.json that we just created. Since we will be using hashing, the module that I will be using is Crypto.js. Let's install and save it to the package.json by running npm install save Crypto.js. So once that's been created, we can start implementing our blockchain application. Let's create a folder called source, where we'll be keeping all of our JavaScript source files. And let's create our first class called block. Let's define the class and name it as block. The class contains a constructor which accepts index, a transaction, and a previous hash as the parameter. Transaction contains data like sender, recipient, and amount. It also contains timestamps and hash which will be created inside the constructor. The values passed in the constructor are assigned to the member variable of the class, and the values for timestamp and hash is calculated. Timestamp will be the date when the block is created. Let's create a function called calculateHash. For this, we require Crypto.js SHA-256, which we need to import to the class using the require keyword. Crypto.js is the standard library for encryption. We'll be using SHA-256 to create hash of our block. So inside the calculateHash function, we'll use all the parameters of this block to create the hash. So basically, the transaction data, the timestamp, the index, and the previous hash is used to calculate the hash of this particular block. Once that's done, let's export the class so that other class can use it. Let's create another class called blockchain, which is responsible for creating the chain of blocks, adding new blocks, and make sure the chain is valid. The class has a constructor with one member variable called chain, which stores a collection of blocks. These blocks will be tied to each other using the previous hash. We need a method to create the first block, which is also called genesis block. To create the block, we need to require the block class, which then can be instantiated using its constructor, using a require method and adding that block into the single quotes. So now we can return new block and provide default values for index, the data, transaction, and the previous hash. In this case, it would be 0 because it's a first block. There will be no previous hash. The next method we need is to add a new block to the chain. Let's call it add new block. It accepts sender, recipient, and amount as a data, which we call here transaction. Let's create a new block, and pass the required parameters. The index would be the length of the chain array. Let's create a method called new transaction, which will return the JSON of the sender, recipient, and the amount. Let's create that method and name it new transaction. So the method will basically return a JSON representation of the sender, recipient, and the amount. Now we can call this method when creating the block and pass it as a second parameter. The previous hash of the block would be the hash of the last block in the chain array. We can also add a method called lastBlock that returns the last block in the array by using slice method. Let's test what we have done so far. Let's create a file called app.js where we will be creating our own CryptoCoin. In order to do that, we need the blockchain object, which can be added as a required keyword from the source folder. Once the object is instantiated, let's add a couple of blocks to the chain. Since the block requires sender and recipient account number, I'll be using the random method from the math library to create random account numbers. And convert that to a string and copy the same as a recipient and add $5,000 as an amount, and also add a second block to the blockchain. Once the block is created and a chain is formed, we can log the JSON output into the console to test it. Let's run the app using npm start. Since npm start failed, we need to add start command into our script package.json and to run app.js using Node. Now when we run npm start, we see the chain that we have created. Since we have added just one block into the chain, we just saw a block. So every time we add a block, we also need to add it to the chain. So in the add new block, we need to add each block to the chain as well. Once added, we can run the npm start again and we see all the blocks that we have added. Each block has a hash, previous hash, and the transaction data, along with the timestamp on when it was created and its index value. Now, let's add logic to make sure the change is valid. We add a method called isChainValid. The method loops through each block and makes sure the hash equals the calculated hash and the previous hash of this block is equal to the hash of the last block. For this, we use the forEach method, which applies to an array. We will skip the first index as it's the genesis block. So if index is equal to 0, then we'll just return. So if the hash of the current block is not equal to the calculated hash, then the block is not valid. Let's add a local variable called isValid to store the validity. The next thing we need to check is the previous hash. If the block previous hash is not equal to the previous block hash, then we need to return false. So the isValid will be false again. To get the last block hash, we get the block from the array in the location index -1 and get that particular block's hash and return the isValid variable from the function. Let's make sure the chain is valid by calling isChainValid method of the blockchain class. Let's log the return value of that method in console, and it should return true as expected. Let's run it again using npm start. Once we run npm start, we can see that isChainValid is true as expected. Now let's tamper one of the blocks data and see if the chain is valid. What I'm going to do is increase the amount of one of the transactions and bump the value, the amount, to some other value. So I'm going to increase the second block amount from 5,000 to 23,000. Let's print the validity again and run using npm start. And as you can see, the validity of the chain is false. This makes all the chain invalid after this block. So there you go. You have created your first blockchain application. Please comment and like this video. I will be covering proof of work in my next video. I will also be posting videos on more advanced blockchain techniques. So please subscribe to my channel if you haven't already. Thank you for watching and see you in the next video.